Let's start with our name and date. As you can see, I've already prepped the beginning of our notes. We are doing lesson 4.2, determining slope and y-intercept, which is pages 95 to 100 in your book. Our essential question is, how can you determine the slope and the y-intercept of a line? And we have a vocabulary word to start with today. We've already talked about slope, but now we're going to add in y-intercept. That is the y-coordinate of the point where the graph intersects and crosses the y-axis. And the point is always going to be in the form of 0, b. B standing for the y-intercept value. The x is always going to be 0 because we're on the y-axis, which means we don't move on the x-axis. Now, you have a problem on page 95 in your book. It says the graph of every non-vertical line crosses the y-axis. This is the y-axis. You can see the line crossing it. The y-intercept is the y-coordinate, which we just discussed. This graph represents the linear equation y equals negative 2/3 x plus 4. And we can use information from the graph to prove the slope and the y-intercept, and that's what I'm going to do. So I will quickly sketch that graph for us. Plot that quickly. I'm going to draw that line in real quick. Okay, so this would be the graph that's there on page 95. And we're going to look at this. This point here is 0, 4, because you went nowhere on the x-axis, you went straight up to 4. This point here is negative 3, 6. Now, using that information, I can go find my slope. I can find my slope, which is m. That's what the letter that we use for m, for slope. And I'm going to find my change in y. So 6 minus 4 over my change in x, negative 3 minus 0. 6 minus 4 is 2. Negative 3 minus 0 is negative 3. If you don't believe me, use your calculator. So my slope is negative 2/3. We were given the equation y equals negative 2/3 x plus 4. We just used 2 points from this line to prove the slope. This is my slope right there. That's where it is in the equation. This is where I'm crossing the y-axis. This is my b right there. That's how the equation works. That's how we get the equation of the line from a graph. On page 96 in your book, we have an example talking about a phone salesman. paid a minimum weekly salary and a commission for each phone sold as shown in this table. Confirm that the relationship is linear and give the constant rate of change in the initial value. I want you to notice here, because I'm not going to write this in the notes, notice here, if we take 630 minus 480, that's our y, that's 150, and then 20 minus 10, because we have to use the same points. 150 divided by 10 is 15. If we do that between these two, we come up with 15. If we do it here, we come up with 15. So our rate of change is constant. And what that constant rate of change is, he's getting a minimum weekly salary and a commission. That rate of change is the commission. Okay? So, we have example 1. And here's what we're going to put in our book. So we have the number sold over the weekly wage. And if there were 10 phones sold, he made $480. 20 was 630. 30 was 780. 40 was 930. And as I just showed you in the book, the rate of change is constant because it's $15. And that was the commission from each phone sold. Now, the problem is, the piece of information we're not given is what his weekly salary was before he sold any phones. So we need to go and find the weekly salary before commission. And what you're going to do is you're going to back the table out. In other words, we don't want to know 10, we want to know the missing one here, which is 0. And I can just use this one and add it on here. So that's what I need to go find, is when he sold 0 phones, what was his weekly salary? If I check here to here, I subtract 150. From here to here, again, I subtracted 150. To go from here to here, I subtract 150. So to find this amount here, I need to do 480 minus 150, and I will find that his weekly salary is $330. Now, what we've done here is we've used the table to find the starting salary, which means if I wanted to take his rate of change, which was $15 for each phone sold, we know his weekly salary now starts at $330 a week before commission. What if I wanted the equation? Remember, our Y is his salary. It's what he actually gets on his paycheck. The X is the number of phones sold. Well, he gets $15 for every phone. So I would put 15x plus, if I was graphing this, that would be his weekly salary right there. And that would be our equation for that problem. That is how we would figure out what his weekly salary was. Okay, time for the quick check. And your quick check today is page 96, the Your Turn, number 1 and 2. Let me show that to you. Page 96, Your Turn, it's here at the bottom of the page, numbers 1 and 2. And then I also want you to do page 97, the Explore activity. Deriving the slope-intercept form of an equation. I want you to go through and answer all of this and see if you can come up with y equals mx plus b. That's what you should have there, is a b. And then there is a reflection at the bottom. So I want you to do that whole Explore activity on page 97. We will see you tomorrow.